Welcome to this talk on the 6 thinking hats, which is a powerful tool, a powerful method of improving thinking in the classroom and indeed elsewhere. Supposing I were to ask you, what do you think is the most important invention that mankind has ever made? Well, you might say, of course, the computer. Computer can enable us to do wonderful things and getting better all the time. You might say a space rocket, which can enable us to go to the moon and beyond to Mars. There's all sorts of things you might say. But supposing I were to suggest to you that the bicycle, the very simple, humble bicycle, is one of the most important inventions ever. Now, my reasoning is simple, that what the bicycle does, and this will more or less look like a bicycle, what the bicycle does, it allows a human being to use his or her muscle energy in a much more effective way. In other words, the bicycle doesn't use any other energy, as indeed a rocket does, or to some extent a computer does, although a small amount of electricity, but to use human energy in a much more effective way. Now, of course, if we imagine 2 people having a race, and they set off to run the race, and let's suppose this is a rather fat person for the moment, the thin person will obviously or likely go faster than the fat person. But now if we train the fat person to learn how to ride a bicycle, then once that person has learned, that person will go much further and much faster than the person without the bicycle. Of course, there is a learning period in which the person learning to ride the bicycle may not do as well as he or she would have done without the bicycle. But what the bicycle does is to allow us to use our human abilities much, much more effectively. Even if we look at a simple ladder, what does a ladder do? A ladder allows us to use our human muscular energy to climb to higher places in a way that is much easier than we would have to do without a ladder. So these are ways of improving the use of our existing abilities, energies, skills, and so on. I'm going to put down some figures. Now, what I want you to do is to add all those up as quickly as you can. Just add all those up as quickly as you can. Nothing magical about it, simple arithmetic. Add them up as quickly as you can. Well, that's not so easy. But let's suppose I put them one under the other. Now that becomes much easier to add them up. Now, what have I done? I've simply changed the position, just put things in such a way that it is easier to deal with them. Just as simple as that. But it makes a huge difference. How we put things makes it much easier to deal with them. Let's look at another example. Suppose I ask you to add up the numbers going up from 1 to 10, all the way up to 10. Not too difficult, and you'd reach the answer 55. Supposing I said to you, let's make it a little bit more difficult, and I want you to add up all the numbers from 1 to 100. Well, it's easy, it's not complicated, you might make mistakes, it would take you a long time. But let's rearrange it. Let's rearrange it in a different way. And let's put our numbers going up. And this time, underneath, we'll write the same numbers going backwards. And all the way backwards. Now we add them up. We add the top line to the bottom line. We'll always get 101. Because as we add 1 on the top line, we subtract 1 on the bottom line, the total stays the same. When we've finished, we'll have 100 times 101, twice as many as we need, and the answer is 5,050. Now, there we're rearranging things so we can do something rather more complex and do it more easily. Now, that's what I'm going to be talking about, really, about how we can rearrange things in our brain, in our mind, so that we can think more simply and more effectively. There's no magic about it. We're using the existing brain ability as such. Let's for a moment look at the relationship between intelligence and thinking. And perhaps the best way of describing that relationship is to look at the relationship between a motor car and the driver. The horsepower of a car, the engineering, the suspension, all that is the potential of the car. Just as intelligence is the potential of the brain, possibly determined by the speed of transmission along the neurons in the brain. But the way the car performs does not only depend on the horsepower. The way the car performs also depends on the skill of the driver. The skill of the driver. You may afford to buy a very powerful car, but you may be a bad driver. You may only be able to afford to buy a much more humble car, and yet you could be a very good driver. So one is a potential, one is the skill with which that potential is used. Intelligence is the potential of the mind, thinking is the skill with which it is used. Now, I've taught thinking to classrooms ranging from one class made up entirely of Nobel Prize winners, and at first they said, how can anyone teach us thinking? We've won Nobel Prizes. But at the end of 3 days they went away saying, yes, these things work, so much so that 3 of them then wrote forwards to one of my books. So at one end of the spectrum, very intelligent, very gifted children, we need to teach thinking, otherwise we're wasting that superb intelligence. At the other end of the spectrum, with youngsters of perhaps lesser intelligence, we also need to teach thinking in order to make the best use of what is there, and of course all in between. That is why in many countries now, the idea of teaching thinking as a skill is so established that by law every child in school must do 2 hours a week on thinking skills. So we're looking at thinking as a skill. You could also look at it as a form of software. If you buy a computer, you don't go home and say, I bought this wonderful computer and it's a Pentium 150 and it's got 3 gigabytes of storage, and you say, well, I really don't care about the software. Clearly, no matter how wonderful the computer is, without software you're not going to get anywhere. So what is the software that we use for the human brain? The most important computer of all, and indeed a vastly superior computer to any others, what is the software we use for that? And it's very limited and not really adequate for the functions that are necessary today. So we're looking at some sort of software for human thinking. Now, I'm going to describe a very, very simple form of software for thinking. It's widely used and it's very powerful. I'll just give you an example of just how widely used it is. Last June, I got 2 letters the same day. One letter was from the head of research of Siemens. Siemens is a big company in Germany. It's by far the biggest company in Europe. They employ 370,000 workers. Their annual turnover is $59,000 million. Big company. The head of research at Siemens wrote to me, and he said, we were using your 6 hats at our last top research meeting, and that was very successful. Same day, I get another letter from a young man called Simon Batchelor, who's in Cambodia, and he's there to help the Khmer villagers drill for water in their villages. And he could never get the villagers to be involved in the processes in the drill. They just weren't interested. And what he was looking for was some way of getting the villagers to be involved. He had his daughter with him, who was out of school, so he had one of my books called Teach Your Child How to Think. From that, he took the 6 hats, started teaching this to the Khmer villagers. Apparently, they became so enthusiastic, they said this is far more important than drilling for water, and the whole mission changed to teaching them thinking, teaching them the 6 thinking hats. Some days later, I was in Wellington, New Zealand, and the head of Wellesley College, one of their leading schools, says we teach that routinely to our 5-year-olds. So there we're looking at this framework of thinking which I'm going to talk about, which really goes across from top executives in one of the world's largest companies to 5-year-olds via Khmer villages. A very, very simple process. Now I want to emphasize that particularly because the process I'm going to talk about is very simple and very practical. That's a key point. Sometimes in education people say if something is simple, it can't really be worthwhile, and people want things to be very complicated, and then they say they're very worthwhile, but unfortunately we can't use them. So we're going to be looking at something very simple, very powerful, very effective. Now let's look for a moment at the whole business of teaching thinking. And I'm not going to go into this in great detail, but just in some detail. First, we might say there's osmosis. And we say if we have a very gifted teacher and a long exposure to youngsters, then some of the skills, the thinking habits of that very gifted teacher will transfer to the youngsters. And that is certainly true. It does happen, but it's not very practical because you need a long exposure and you also need a lot of very, very gifted children. So as a practical process, that really doesn't work. Then we might say, if we wait for children to make mistakes in thinking, and then we correct these mistakes, clearly children will make, or youngsters, students, pupils, will make thinking which has no mistakes, and therefore it's going to be very good thinking because it has no mistakes. Unfortunately, that's not true. Suppose you said we're going to teach people how to drive a car by making it so that they don't make any mistakes. Well, the simplest thing to do is to leave the car in the garage, and you won't make any mistakes, but you won't get anywhere either. In other words, just avoiding mistakes is totally insufficient. We need the generative, productive aspects of thinking. Just avoiding mistakes is not enough. Then we might say we're going to have discussions, and we're going to have children discussing some subject, and as they discuss it, we're going to encourage them to use better thinking, and we're going to hope they're going to abstract these thinking points and then perhaps use them elsewhere. Unfortunately, that doesn't happen well either, because if your attention is on the subject of the discussion, it's very difficult to pay attention to the abstracted points. So the process which I prefer is the tools process. Tools process means we create some tools, some frameworks, which we then practice on different situations. That embeds skill in the tool, and then you take the tool and you apply it elsewhere. In other words, the skill is portable. You can take it and apply it anywhere. And that's what we're going to be looking at. One particular tool, one particular frame. Now, it's true that some people say, quite rightly, they say whatever we're teaching, whatever subject we're teaching it in a thinking manner, and surely if we teach subjects well, then thinking is going to improve. Youngsters, students are thinking all the time, and if you're thinking all the time, surely your thinking will improve. Not necessarily so. Imagine that you are a typist. In the age of 15, you start typing with 2 fingers. And suppose you become a journalist, and for the rest of your life you're typing hundreds, maybe thousands of words every day. At the age of 60, you will still be typing with 2 fingers. You might now be a very good 2-finger typist. Similarly, the fact that you're thinking does not make you better at thinking. It only makes you better at that particular type of thinking you're doing. So if you're a bad thinker and you practice a lot, you will become an excellent bad thinker. You won't suddenly change to becoming a good thinker. Now, if that youngster at the age of 15 had taken a 5-week course in touch typing, then for the rest of that youngster's career, that youngster would have been a touch typist. So we need to teach thinking explicitly, directly. The notion that it'll just rub off because thinking is being used in other subject areas is not sufficient. We can do things very directly. Now, the particular frame that I'm going to talk about in a little while is very powerful. For instance, IBM use it at one of their top laboratories. They found it reduced meeting times to 1/4 of what they had been before. Indeed, a friend of mine was involved in jury service, 2 parallel cases. The first case, the jury deliberated for 4 hours to reach a conclusion. Second case, using the 6 hats framework, within 15 minutes, they had a solution. Much, much quicker. There was a simple little exercise I did on some senior public servants, and these were mostly university graduates, and I asked them to think about a subject and then crossed over the subject and asked them to use the hats on it, and they had a 493% change in their thinking. In other words, almost a 5-fold increase in thinking productivity using the very simple frame that I'm going to talk about now. What do we mean by a frame? Well, imagine we send an explorer off to an island, and this explorer comes back and we say, what did you see? The explorer says, well, there was this volcano in the corner which was smoking, and there was this funny bird which didn't fly. And you say, well, that's fine, but what else did you notice? What else did you see? And the explorer says, well, that's all that caught my attention. So you send the explorer back, and this time you say, very simply, I want you to look north, take your notebook, see what you see. I want you to look east, take your notebook, and south, and west, and so on. When you come back, you'll have a much fuller scan of that island. Now, what is north, south, east, and west? They are just frameworks for directing attention. So the framework I'm going to be looking at now is one which allows us to direct attention, allows us to do one thing at a time. And that is very, very important. One thing at a time. Often when we're thinking, the main problem is confusion. We're trying to do everything at the same moment. So two things happen. One is we are confused. The second thing is, unless we have frames to direct attention, we only see a very small part of what there is to see. So we're going to be looking at the 6 hats, which is a way of directing attention, a way of doing one thing at a time. Now we need to go back to what our traditional thinking is. Where did our traditional habits of thinking come from? And we go back to the fall of Rome in AD 400. After the fall of Rome in Europe, there were the Dark Ages. Dark Ages because we don't know much about them, because the great learning, reading, writing, scholarship of the Greek-Roman period disappeared. Then came the Renaissance. Renaissance was the rediscovery of classic Greek-Roman thinking. This was like a breath of fresh air, allowed humankind to use logic and reason to work things out, gave humankind a more central position in the universe. So this wonderful new thinking was eagerly adopted by civilization, both by the church and the non-church, became the dominant software of Western thinking and has remained so to this day. But what was this wonderful thinking? We need to go back in history again to 400 to 300 BC, and the Gang of Three. First of the Gang of Three was Socrates. Socrates was mainly concerned in showing why things were wrong. Socrates was very interested in dialectic or argument. In 80% of the discussions in which Socrates was involved, there was no constructive outcome. And when his listeners said, you say everything is wrong, so what is right? Socrates would say, not my business. My business is to say what's wrong. Now, for his purposes, this was absolutely correct. Socrates was trying to find out how people used words like love, justice, courage, and so on. So just as if you were discovering the rules of grammar, if you say, well, that's a bad use, and that's a bad use, and that's a bad use, in the end you are indeed left with the correct, the right uses. So for his purposes, that was fine. But the emphasis was very much on saying, if we can show what is wrong, we will be left with what is right. Then there was Plato. Plato was very influenced by Pythagoras, who had shown mathematical truths. You may remember Pythagoras' theorem in a right-angled triangle, a squared equals b squared plus c squared. Plato was very interested in the truth. What is the underlying truth? Then we had Aristotle. Among other things, Aristotle believed that men had more teeth in their mouth than did women, and although he was married twice, he never asked either of his wives to open their mouth to count their teeth. He didn't need to because he knew. With horses, the stallion has more teeth than the mare, so he established as a general principle that the male of the species has more teeth than the female, therefore he had more teeth than his wives, and that was easier than counting. They probably had bad breath anyway. Now, so what Aristotle did, he said, from the past, let us create boxes, categories, definitions. Then we come across something, we analyze it down so we can recognize it, then we judge, does it fit in this box or does it not fit in this box? Something could not both fit and not fit, and it couldn't be anywhere else. Those are Aristotle's two principles. From that arose our method of thinking, which is very largely concerned with argument. In argument, A has a point of view, B has a point of view, they argue, B seeks to prove A wrong, A seeks to prove B wrong, occasionally you get the synthesis of both. Now that system is fine, it's a very useful system, very useful for discovering the truth. But it was never designed to be constructive. It is a system which is very lacking in constructive energy, very lacking in creative energy, very lacking in design energy, because it was never intended for those purposes. It was intended to discover what is the truth. Now, in a stable world, that's fine. In a stable world, the boxes from the past are every bit as useful in the future, but not so in a changing world. In a changing world, the boxes may not apply. In a changing world, we need design. How we put things together. It's the difference between what is, existing knowledge, existing routines, and what can be. Creativity, construction, design. All our emphasis has been on that, not enough on what can be. So we need to develop, we need to invent a constructive idiom of thinking which is not normally part of the Western tradition of thinking, which has a very good idiom for discovering the truth called argument, not one for designing something better. So that is where we come to parallel thinking. Parallel thinking, instead of A arguing with B, A and B are thinking together, in parallel, in the same direction, cooperatively. Now, of course, we need to vary the direction. And for that, we invent a very simple framework, which is the 6 hats. 6 hats means that as someone sits thinking, there are imaginary, metaphorical hats which you put on or take off. You wear one hat at a time. Now, what are these hats? Well, we start with the first hat. The first hat is the white hat. You can think of white as paper, printout, computer printout. White hat is what information is available, what information is needed, what information is missing, and, very important, how are we going to get the information we need. White hat is a direct focus on information. When the white hat is in use, everyone in that group wears the white hat. Everyone is focusing on information. If the information does not agree, even if it's contradictory, you put it down in parallel. You accept both versions. Later, when you come to design the outcome, you need to decide between them. Then you decide between them or design something which satisfies both. So that's the white hat. Direct, exclusive focus on information. Then we move to the next hat. The next hat is the red hat. You can think of red as far and warm. The red hat is feelings. Feelings, intuition, and emotions. Normally in thinking, you're not supposed to allow your emotions to come in. Of course, they come in anyway, you just disguise them as logic. What the red hat does, it allows you to signal that this is your feeling. You're not pretending it's anything else. Now, intuition can be based on a lot of experience in the field, which comes together to give you a gut feeling. That is very useful. Does not mean it's always right. It's not always right. When they told Einstein about Heisenberg's uncertainty principle, Einstein says, my intuition says that's wrong. God doesn't play dice. Nature doesn't work that way. Turned out the great Einstein's intuition was wrong. Heisenberg was right. But the red hat allows you to put forward intuition, feelings, emotions without any need to explain or justify them. Then we come to the next hat. The next hat is the black hat. You can think of black as the judge's robes. The black hat is caution. Caution. Caution, risk assessment, and critical. Why something doesn't fit our ethics, our value, our budget, our policy, whatever it is. Black hat is an extremely useful hat, possibly the most useful hat, because it stops us doing things which are dangerous, damaging, polluting, and so on, illegal, and so on. Very, very useful hat. But it is very easy to overuse. Now that's rather like wine. Wine is excellent, tastes nice, and reduces the incidence of heart attack. At least it does if you're a Frenchman. But too much wine can give you cirrhosis of the liver and make you an alcoholic. That is not the fault of the wine. That is the fault of overuse. Food is necessary. Too much food can make you overweight with possible health problems. Not the fault of the food, the fault of overuse. Now, the reason I emphasize this is far too many people believe somehow the black hat is a bad hat. It is not. It is an excellent hat, possibly the most useful. But with it, we look at the caution areas, the difficulties, the dangers. That does not make it a bad hat. A judge who's sitting in court deals with criminals most of the time, does not make the judge a criminal. Keep that very clearly in mind. Black hat is evaluation, caution, very, very important hat. Then we come to the next hat. The next hat is the yellow hat. I draw brown because yellow doesn't show too well with my pens. That's the yellow hat. The yellow hat is the logical positive. In a sense, the black hat is the logical negative, but on the whole, I don't like calling the black hat negative because people get the wrong idea that somehow it's a bad hat. Yellow hat, logical positive, we make a strong effort to look for benefits. Benefits, values, and how we can make something work. But we must show the support for it, the logical reasons for it. The yellow hat, the logical reasons. Yellow hat is much, much more difficult than the black hat. Black hat is very natural. The brain has a very natural mechanism for saying that is not what I'm used to, that is not what it's supposed to be. That is very natural. The brain does not have an equivalent mechanism for saying that has benefits, that has value. Therefore, we need really to develop that yellow hat attitude. Looking for benefits, looking for value, it does not come as naturally as the black hat. So very key hat. We need to develop a skill in doing it. We need to develop what I call value sensitivity. Value sensitivity, the word sensitivity is the same as sensitive photographic film. Value sensitivity means that we develop a high sensitivity to value. If we look at that with a golfing analogy, imagine you're playing golf and you get the ball on the green and then you try very hard to get it in the hole. And some people think that's important. Now, just imagine how much easier golf would be if the green was shaped like that. So when you got the ball here, it rolled down by itself and got in the hole. That's the same with value sensitivity. If you don't develop value sensitivity, then you've got to see the value directly staring you in the face. But if you develop value sensitivity, then from a distance, you can sense the value and come towards it. So yellow hat, value sensitivity, very important part of thinking.